Hi all, this video is to show you how to draw the ray diagrams for the total internal reflection for the prisms. Okay, so here first we have to draw the outline of the prism. First I am considering the totally internally reflecting prism, that is the 45 degree, 90 degree, 45 degree prism. Okay, and to draw this prism, as you draw a triangle, you can use the usual method, that is by using a scale and the protractor you can proceed it. Then second method is to I will show you one simple method by using the set square. Okay, so in your instrument box you have two different types of set square. Choose the small one for 90, 45, 45, because the angle between these two sides, here it is 90 degree and the angle of the side it is 45 and here it is 45. So to draw the outline of 45, 90, 45, use this small set square. Keep it on the paper. You can use the other method also, no problem. Okay, draw the outline of this set square. Afterwards extend the lines to get sharp corner. So make all the corners sharp. Okay, then label the prism as A, B, C and mark all the angles. 90 degree, 45 degree, here is 45 degree. Okay, this is the first initial stage. Then next we have to draw the normal incident ray. Here we will be considering only the normal incident ray, and draw the normal incident ray to one of the sides. Here I am choosing the side AB. Okay, so mark the point of incidence at the side AB. Then draw the normal incident ray. Normal incident ray means we know the ray which is passing through 90 degree line. Okay, so at this point of incidence, when you draw the normal is always to the surface of your prism. Okay, so when you draw the normal, 0, 0 of your protractor should be along the surface of the prism. Okay, so mark the point of incidence and at that point keep your protractor baseline 0, 0. Then mark the 90 degree, mark 90 degree. Okay, or the same set square can be used. So here the angle is 90 degree. So here it is, keep it like this. Make it coincide, one side make it coincide with your side of the prism. Then draw the line. Then extend it to the point of incidence. Then mark the direction of the light ray and name the light ray as PQ. You can choose according to your wish, you can choose the letters, and here PQ is the normal incident ray. So at the side AB, PQ is the incident ray. Light ray is passing from rarer to the denser media, and this side also we are having the rarer media. Okay, so now the light ray passes from rarer to the denser media, and moreover this is a normal incident ray, so that what happens to the light ray, it will move to the next media irrespective of the density, because it is the normal incident ray. That means what will be the value of angle of incidence at the side AB? I is equal to 0 degree. And what about what happens to the light ray? No deviation or the no refraction takes place. Okay, so at the side AB, due to angle of incidence I is equal to 0, no refraction takes place, so that what you can extend this light ray to the next side, next media glass, till it touches the next surface of the prism. Okay, and marking the direction and labeling the ray as QR. So QR is the incident ray for the side AC. Now your ray is inside the glass, that is in the denser medium, and it is approaching the rarer medium. So denser to rarer, chances are therefore normal refraction to takes place. Normal refraction and total internal reflection also, two chances are there. So when the light ray passes from denser to rarer, you should check whether it will be normal refraction or total internal reflection. So what is the condition for normal refraction? Angle of incidence should be less than the critical angle, and for total internal reflection, angle of incidence should be greater than the critical angle. Okay, so at this point, mark the point of incidence at the surface AC because it is passing from denser to the rarer media. Mark the point of incidence and draw the normal to the side AC. So here also keep the protractor 0 0 because you are drawing the normal, so 0 0 along the surface, mark the 90 degree. Okay, or else the same method you can use the set square to that point of incidence, draw the normal. When you draw the normal, you should use only the dotted line, not only for the normal. When you produce the rays forward, backward and all, you should use the line dotted one. Okay, so this is the normal and labeling the normal as n dash. Now what is the aim? Now light ray passes from denser to the rarer medium and we should measure the angle of incidence. So measure the angle of incidence, angle between the normal and the incident ray for the side AC. So QR is the incident ray, so this angle measure it using the protractor. And when you measure the angle of incidence, angle of refraction and all, 0 0 of your protractor line should be along the normal when you measure the angle of incidence and angle of refraction. So let it be like this. Okay, 0 0 along the normal. Then see what is the measurement you are getting. Take this measurement. Okay, so this is 45 degree. So now here we got the angle as 45 degree, light ray passing from denser to the rarer medium. So what is the value of the critical angle for glass air interface? Critical angle value is 42 degree. Okay, so compare this angle of incidence with this 42 degree critical angle. What is it? Angle of 45 degree is greater than 42 degree. So what is the condition? I is greater than C. That means total internal reflection takes place. Okay, so at the side AC, at the side AC, what is the value of angle of incidence? It is 45 degree and condition it is what? Critical angle is 42 degree, so that I is greater than C. So chances for total internal reflection to takes place. Total internal reflection means this light ray will be bending inside the or bouncing back to the denser medium itself. Okay, and what about the angle of reflection? We know since it is a reflected ray, it must obey the law of reflection, that is angle of incidence should be equal to angle of reflection. So the angle of reflection also must be equal to 45 degree. So use your protractor to take the angle of reflection, that is keep it along the 0 0 along the normal. Then take the measurement from here because we know angle of reflection is the angle between normal and the reflected ray. So normal and the reflected ray means 45 degree here. Okay, so marking the 45 degree and drawing the ray till it touches the next side of your prism BC. Okay, put the arrow mark to represent the light ray. Then mark the angle of reflection as 45 degree. Then still our light ray is in the denser medium. Okay, and it is approaching the rarer medium. So again you have to measure the angle of incidence. So now our light ray reached the side at the BC. So at the side BC, what happens? We need to measure the angle of incidence. So to measure the angle of incidence, we need to draw the normal. So at this point of incidence S, marking as S, keep your protractor and we need to draw the normal. Okay, so just see what happens. See, our light ray RS is on the normal itself. Okay, so it is for RS is normal incident ray for the side BC. So extending, that is angle of incidence is equal to 0 degree. Normal incidence means angle of incidence will be equal to 0 degree. Okay, so what happens? No refraction takes place. Okay, and thus we can extend the ray to the next side like this. Okay, so ST is your emergent ray. So this is the method to draw the ray diagram. Practice it and send me.